Hi, my name is Neha Bayal, and today we are going to learn about sets in particular. And when it comes to sets, we are going to cover these topics. We are going to understand its meaning with the examples. Then we are going to talk about the representation of it. Then we are going to talk about certain examples regarding it. And then we are going to talk about two methods, roster or tabular form, we call it. And in that specifically, we are going to talk about the order, how it matters, how it doesn't matter, that kind of thing. And then we're going to talk about the set builder form. And the last thing would be some questions regarding the conversion of one form to the other. Okay, so that would be the entire flow of the class. So let us just start with the first thing. So when we say sets, okay, so if I start to ask you what are the sets, there could be one commonsensical thing that could come into your mind that it could be collections, right? So if we are talking about all the students in the school that are wearing the white shoes, even the school is actually too big. We can go for one class. So the students who are actually having white shoes. So I have basically defined a particular thing in here that I want these kind of students only. Okay. So the idea here is that will form a set. So the idea here is that it's basically a collection, but do we call all kind of collections as set? Okay. So the answer for that is a no, because I give you a very specific property that the students with the white shoes, right? So this is something I have given you in a well-defined manner, right? So this well-defined word matters a lot in the set definition. So when we have to talk about set definition, this is how we go about it. We say sets are basically a well-defined collection of objects. Now we need to understand this well-defined word a little bit more. Okay, so if I am saying that I want to make a set of all the tall guys in the class, okay, all the tall boys in the class, I want to make a set out of it. Okay, so if I am talking about this, all the tall boys in a class, is it a set or not? Okay, so do you even understand what tall is? Is there any objective criteria regarding a person being tall? Okay, for me, somebody having 6 feet height could be tall. For somebody else, it could be like 6'5". Okay, for somebody else, it could be 5'8" is taller. Okay, so it's very subjective. Okay, so we do not have any objective criteria for that. We cannot call it a set. Okay, so okay, then what can we call a set? Let's say all the prime natural numbers. We very well know what the prime numbers are. There's a specific definition for that. Okay, so we can count that on our, like these are the prime natural numbers 2, 3, okay, 5, whatever does not cut. It's whatever it does not get cut by any other number. Okay, it is just get cut cancelled by or not exactly cancelled, but you can basically divide it by itself only, right? Or one. So that is prime and natural numbers. You all 1, 2, 3, 4, 5 up till infinite. So it is the same. Okay. So in that manner, you can just try thinking of other examples as well, like what could form a set and what could not form a set. Okay. Then we can say, let me just give you one more example. Set of beautiful flowers. Now, is there a objective perspective regarding beauty? I don't think so, right? Okay. So whenever you are talking about the sets, you will have to make sure that you are talking about a precise, well-defined thing. when it comes to its property. So next thing would be the representation. Okay. So let us just learn the representation for it. Very simple thing that we have to keep in mind. Some notations we have to follow when it comes to sets. So sets are basically an idea, right? And we're talking about how do we express that idea. So the way that has been chosen for expressing that, firstly, you are going to have this notation of a capital letter to represent any set. Okay, capital English alphabet. Okay, for example, ABC, anything, A, B, C, D, E, F, G, H, anything from A to Z. Then, whatever is inside the set, you have to write it within the curly braces. What do we call it? The curly brackets. Okay. This is how it looks like. Okay. And if although there are going to be two forms that we're going to study regarding it, when it comes to the specific one, the tabular one, there you separate it by comma. Okay. I am writing that here because this is the most generic way of writing it. Like mostly this is how we write it. Okay. But there is another form that is also used, which should be another one that's a builder form. Okay. The roster form is for this that you separated by commas each and every element. For example, I start to show you that there's set A, which is containing 1, 2, 3. Okay, so this is how I write it. A is equals to 1, 2, 3. Understandable. We can move towards the next thing. Okay. So yeah, just give me a second. Okay. Now, in the set notation, there is one more symbol that we talk about. This is how we make it. Okay. Either this way or instead, let me just write it in this way. So this is the symbol that we talk about. Belongs to. And if I mark this, if I make a sign like this, then I will be calling it does not belong to. Okay, does not belong. Now, what's the usage? How do we use it? Firstly, let me just take the set that we already have. If I have to talk about one, okay, I can simply write one belong to A because it is already a member of it. Okay, what are these called? These are called actually the elements of set A. Okay, or you can say member. So basically, one actually belongs to A, or you can say one is a member of A. So you are going to use the symbol when that particular element is in that set. If it is not, you're going to use the another symbol. For example, I can say 4 does not belong to A. Simple. Let me show you one more example. Let us take a set B. It is of certain animal set. Let me be very specific. Cat, dog, and let's say sparrow. We have taken a bird. Okay. So if I start asking you this particular question that fish belongs to B or not? Okay. So the answer for that isn't it very clear? It's not part of the set. It's not written as an element of the B. We will obviously be saying no. Okay. It is not. If I have to talk about dog or a cat or a sparrow, I can talk about, it belongs to bee. So basically, you can say fish does not belong to bee. Simple. Okay, there are certain famous sets that all of us needs to know. So I'm going on to that. Famous sets. Let me just, or we can call them. Let's keep it famous sets only. Okay, let us just go for this natural numbers. Okay, how do we represent a natural number? So, there are some specific notations that are used for these particular sets. So whenever I'm talking about the natural numbers, which are these, n is equals to 1, 2, 3, 4, 5, like that we can go on till infinite, right? So for that, I am supposed to basically use capital N only, or any somebody is writing capital N. Most probably, it means that it has been used in this context only for the natural numbers. Okay. Next is the whole numbers. Now, whole numbers are basically natural numbers, but it contains zero as well, along with all the natural numbers, right? It is represented by W, and it is very easy to remember these notations as well because wholes W has been taken, natural numbers N has been taken. You can see that, right? To basically make these notations 0, 1, 2, 3, and up till infinite, we can go in the set, right? And one particular observation you can make here that it's not necessary that all the set has to be finite, right? It could be infinite as well. You can see both the sets we have written are infinitely. Now, the third one is in teachers, although some books write sometimes I as well, okay, depending on if it is positive or negative. For example, they would use I positive or I negative or even I as well. So, like positive is for the positive integers, negative is for the negative integers. But the notation that is most commonly used is Z. Okay. In the same way, you can go for like Z positive for the positive integers, Z negative for the negative integers. And when it comes to Z, it is going to contain all the inputs that are there. So 0, 1, 2, and you can go on till infinite on the positive end and negative infinite on the left end. Okay, like that. Now the fourth one is the rational numbers. Okay, the rational numbers we're supposed to represent by Q. Although it's a bit hard to remember, but yeah, this is one thing that we can try to memorize. Q. We represent it by Q, and Q basically contains all the numbers because I haven't taught you yet the set builder form, so I cannot use that here. So I am giving you in this way numbers of form P by Q, where Q is basically not goes to 0. Okay, example for them, very simple. 1 by 2, minus 3, 5. Even minus 3 and 5, which are already integers, are also part of the rational numbers. You need to understand that because if there is nothing as a denominator, 1 is the denominator. Basically, minus 3 is basically equals to minus 3 by 1. Okay. So I'm hoping that this particular concept is understandable for us. And 5 is basically equals to 5 by 1. Okay. Now, let's move to the next one. Next is irrational numbers. We should, although there is no standard notation that we actually read regarding them. It's just that we need to know whatever cannot be written as P by Q, that would work as what? That would work as the irrational number for us. Also, yeah, this needed to be written in here as well. You can consider your P and Q as belonging to the integer fraction. Okay, because the negative fractions are also taken, right? Okay, so yeah. Now, next thing is, let me just give you a few examples regarding the irrational number because it is a concept which some students even find difficult at this grade as well. So, examples could be for this if I have to take about, for example, I can take root 2, root 3, root 5, anything. Okay, not actually anything. If you are going to take a root over it and it gives you a normal number in the sense that you can write as a p by q form. For example, if I go for the root 4, it will give me 2. So this does not work here, right? Because 2 by 1 can work for me as a rational number, right? So root 4 is not, I'm not going to write that here. Okay, root 3, pi also will be taken an example. So if you do not understand the irrational numbers, you are specifically supposed to study them. Okay, because you should be absolutely clear about the numbers. Now, next is the real numbers, right? Real numbers. When it comes to real numbers, these are basically going to contain the rational numbers as well as the irrational numbers. Okay, so it takes all of them. Now, I cannot write it as, something like this because it's not very countable. I can write it but in a segmental form that I haven't taught you yet. So I can go for either an interval, this one, minus infinite to infinite, everything in between is included, right? Okay. Or I can represent it with a number line 0, 1, 2, 3, minus 1, minus 2, minus t. And like that, we are going from both sides. It's not just that these numbers in specifically are, included in it. Actually, everything is included in it. Here, 1.5 is also included. 1.001 is included. Everything that is on the number line, every number that you know of. Of course, complex numbers or the imaginary numbers are entirely a different concept that we study separately. Okay, that's not included in it. These are the real numbers that we are talking about. Any number that you know of, it's going to be a real number. Okay. Now, let me come to the next topic that I call as the, representation by two methods. Okay. Although I give you a detail regarding, the methods, the representation, that was very specifically the tabular or roster form, you can call it. There are two ways of writing it. Some sets are not even possible to write in just the, this roster form of yours. So, but let's talk about the method one, first of all. Practice, roster or tabular form. Okay. So when we talk about the roster or tabular form, small example we have already seen. You make a list, you separate that by comma, and you make the curly braces. That's the same thing that you're going to do here. You make the curly brackets like this, and you write each and every element by separating it with a comma. Now, let me write one more. January, February, March. I'm taking some months from here. I've just written them, separating with a comma. Simple. That's how it works. Also, we need to understand one more thing here that the order. Okay, what happens? The order actually does not matter. Meaning, either I would have written the January, Feb, March. Even if I would have written the March, Feb, Jan, that also works, right? Or 8, 6, 4, let's try to do here, number, anything works. Okay, in any order you can write it, it works. Okay, so if that is clear, we can go for the next one also. Yeah, we can go for the next one, but let me just tell you one more important thing. It's not just that the order does not matter. It's one more thing that if the repeated elements are there, na, they do not count. For example, repeated elements do not count. What does that mean? Now you see here. If I have a set like this, 1, 1, 2, 3, I do not, even though it's written there in this way, I'm not supposed to count them as like 1, 2, 3, 4, 5. I'm not supposed to count them as 5 particular, elements. Because how many members are actually there in it? It's 1 is part of the set, 2 is part of the set, 3 is part of the set. In this way, I am supposed to understand it. There is no other way to understand it. I'm not supposed to take consideration of the repeated element. Okay. For example, ABC, C, C. Okay. Is it equals to some A, B, C? It's an equal because n plus 1 basically repetition of element was happening and the same thing was happening in the first example. These two are basically equal. We're not supposed to take consideration of the, repetition. Okay. Now, let me talk about the set middle form. Set middle form. Okay. When it comes to the self-Tabular form, there is very specific way of writing it that you have to always keep in mind. Okay, students have a hard time writing this, so specific, attention needs to be paid while doing this topic. Okay, so you basically going to describe a rule that basically works for yourself. Right. If I was not talking about this now, what would I have said? That there is a set, like what could be the rule? I'm not talking about this particular form right now. I'm just trying to think of a rule that could, like by that, I would have suggested that I'm talking about these three things or these three elements without even taking their names. Okay. So I would say that there is a set. It is containing three what? Three alphabets, three actually small letters in English alphabet. Even the beginning alphabets we can take. Okay. Three small letter. Three beginning. Small beginning letters. English alphabet. Right? Okay, understandable. So in this one as well, we are supposed to describe a rule instead of doing the listing. Okay, instead of listing. One more thing. This is how it is going to look like. There is a unit of such that kind of symbol. For example, you see here. I want to talk about all the even natural numbers that are there. So I want to make a set out of it. This is how I'm going to write it in the set form. Let me just make a notation. So capital A, I am, representing it by. So capital A is actually equals to X. Mostly we take the X only. So X, we do not know what X is. We are going to define it ahead by this particular rule that I have just said. X is such that, this is the symbol for such that, okay. X is such that X is an even natural number. Okay. All right. It is basically an even natural number. If I have to write it in the, closing form, this is how we're going to write it. 2, 4, 6, 8, like that we are going to then find. But when it comes to the set builder form, this is how it works. You have written an x that you do not know yet, but then we defined it that x is such that x is an even natural number. Simple. Okay, let me just show you more examples because this is there is actually a variety when it comes to examples regarding this particular concept. Let's say something d is equals to x is such that x less than 10 and x belongs to natural numbers. Now, what are we talking about here? We're talking about all the natural numbers that are actually less than 10. Okay, if it comes to my roster form, now, this is how I talk about it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Less than 10, 10 is not included, right? And when it comes to like I'm talking about some x, which is less than 10. All the x's which are less than 10. But then I should know as well that which x's are these. Are these real numbers? Are these rational numbers? Are these actually integers? So that particular thing also they have defined. So we have defined. So we could have even two conditions. You see, last time we had only one condition. We can have, two conditions as well, three conditions as well. So it doesn't matter how many conditions we could have, for being able to define. So we should be able to very clearly stipulate our point, that this is what we mean. So C is equals to x is such that x is equals to x square. Now, it might look an odd kind of a relationship, but it is not. You see, I'm talking about all the x's in the numbers where if I square it, I get the same number. Okay, so how many numbers are there for of such kind? I think there would be only one, one number only. So if I take the 1 square, it's going to give me 1, right? So when it comes to the tabular form, it would look like this. Even 0 works here. 0 square is also going to give you 0. So 0 and 1, right or not? Okay. So this is how it is going to look like. They could ask you to belongs to not belongs kind of questions regarding this set data form. Like for example, they can, if this is a description that they have given you, like for the B, they could ask you like if 2 belongs to B or not. Okay, then only this much part they have given. So then you're supposed to think of it like what numbers it is going to entail. So you can think of in a manner that you convert it into the tabular form a little, then you would know. So as you clearly can see that 2 is actually part of it, 2 part of it. So yes, it is basically belongs to the set. Now, I was supposed to talk about certain conversions, right? Conversion between forms. Now, let us just take some examples regarding that. First one. Okay, let us go from the tabular to the set builder. Okay. First, A is equals to 2, 4, 6, 8. Then put it 2, 4, 6, 8. What does that mean? What are these? First of all, let's just try to identify them, like how we can just have a rule for them. What are actually, what we can call them as, like what are the collective, well-defined properties that we can see in them. 2, 4, 6, 8, all of them are even numbers, right? All of them are lesser than 10. Yes or no? If I start talking about all the even numbers, and not even numbers actually, one more property there is natural numbers. All of them are actually natural numbers as well. And nobody is having a negative sign. Or there is not a zero included, right? Okay. So I'm not talking about -2, -4, -6. So even number, but these are the natural ones. So I can add in that as well. I'm taking less than 10. So if I combine all of these, I have a thing that I can call as. So I can call this as even natural number. Even natural numbers which are less than 10. Yes or no? Okay, now. So if this is understandable, let us just write it. What does it look like in the, figure of actually A set now? A is equals to, as usual, we take some x. X is such that x is an even natural number. And due to this kind of enemy, x is actually less than 10. Simple, done, very easily doable. Na? If you're able to identify the well-defined property that are used in there, then it is a very simple job. Now let us go for 100% easy. 1 for 9, 16. Although I wanted to make you, I want to make you do one difficult one as well. But yeah. So 1, 4, 9, 16. All of them natural numbers. Okay. All of them are actually looking like squares of certain numbers. Right? Okay. So how do I call it? How do I call it? Actually, if I want now, I can call them as a square of natural numbers as well. Right? When it comes to combining these two properties. Also, then where we have taken the squares, we have taken the 16. So first one is the 1 plus square, second one is 2 square, third one is 3 square, fourth one is 4 square. So all these squares are consecutive. So I can talk about that these are the squares for the numbers less than equals to 4, meaning 4 is also included. The square for the numbers less than equals to 4. So if I have to combine it, this is how I do it. Let me write it with this only. God, that is e equals to x is such that x less than equals to 4 and it belongs to this. It belongs to n. And yeah, one more property we will have to take now here that we are actually talking about x now. Yeah. We take a fraction, very small fraction. It would be the property. Let me call x is equal to n square. Let that n. I have to be two variables. Okay, there is no restriction of such kind. X is equal to n square, where n actually belongs to the natural numbers and n actually lesser than 4 as well. Now is it understandable? So basically, here we have used two variables to be able to define our, property that is getting followed. Okay, so this is done. Now you are supposed to practice student questions regarding it because they ask questions from this kind. Now next one is build a roster. Okay. I think this one would be a little bit more easier. This is what I have seen in pattern that shouldn't find it more easier. Let's say these set x is such that x belongs to n and x is less than 6. So very simple question. Now I just have to comprehend what they are trying to say here. I am supposed to take all the x's which are natural numbers. So that basically 1 till infinite. But in those as well, I am supposed to keep my natural numbers lesser than 6. So what does it do? It becomes very simple. Okay. When x belongs to n, I took the entire natural number set. Then I see that what are the numbers that are lesser than 6 in it. Those are 1, 2, 3, 4, 5. That so this is something that we can understand here. Let us go for the D1. This is x is such that it is multiple of 3. Okay, multiple of 3 and x is less than equals to 15. Now go one by one only. Whenever you face any difficulty, not just mathematics problems, but in life as well, you're not supposed to get overwhelmed by seeing too many things. You're supposed to take one thing at a time. X is multiple of 3. Okay, there is basically a number which is multiple of 3. What are the multiples? Think in your mind. 3, 6, 9. In the entire 3 table you can think of, and even ahead, like 33, 36. We go till 30 in the table now. Then even ahead we can go. But this x is actually lesser than equals to 15. So I am supposed to take the multiples of 3, but I am supposed to take them till 15 only. Okay. So the tabular form becomes this 3, 6, 9, 12, 15. That so this becomes the final example for us. Now I would give you a closing problem, which is this: E is equals to x is such that x is equals to n upon n plus 2. Okay, when n belongs to natural numbers. Tell me, is it going to contain finite number of elements or infinite number of elements? Okay. Second thing, obviously you're supposed to write in the tabular form. Okay. So this would be the closing problem. Although we have done this some sort of a question like this when it comes to conversion from the which one? What was the last one? The roasted tabular, right? This one. So where we basically replace this. This time I'm giving you in the set builder, and you have to convert it into the tabular form. Tabular form. Okay. All right. So this is it. Then bye bye. Take care. Have a really good day. Make the most of it.